In an earlier video, we talked about equation of a circle when the endpoints of a diameter are given. And there we said if the circle that you're given has endpoints x1, y1, x2, y2 as the endpoints of the diameter, then equation of the circle is given by this neat expression x minus x1 times x minus x2 plus y minus y1 times y minus y2. Now here is one other proof that I would like to show in this video, and this is based on the fact that if you are going to take any point inside the semicircle and draw a triangle. So let's go ahead and say that this is x1, y1 and x2, y2. And if I pick any point either in this upper semicircle or lower semicircle and call this as x comma y, now I have to figure out a relationship between x and y. But here is the idea. If you were to join this arbitrary point on the circle to the points, to these endpoints, then it's going to make a right angle, because there is a theorem in geometry that says angle in a semicircle is always going to be a right angle. So notice slope of this line, so let's write down slope, let's say this is m1 and say slope of this line is m2. Then here is what you get. m1 is y minus y1, that's the difference in y's, over x minus x1, the corresponding difference in x's. And similarly, I can write m2 as the difference in y's here, which is y minus y2 over x minus x2. Now, if the two lines are going to be perpendicular, then I can say that the product of their slopes has to be -1. So in that case, I can write down y minus y1 over x minus x1 times y minus y2 over x minus x2. Is equal to -1. And if I rearrange this, then I'm going to see, so what I'm going to say is I multiply the numerators y minus y1 times y minus y2 is equal to negative of x minus x1 times x minus x2. Now if I add this quantity on both sides, then that's what I get. Oops, this is equal to 0. So in other words, if I add this quantity, I get x minus x1 times x minus x2 plus y minus y1 times y minus y2 is equal to 0, which is what we were required to prove.